Hey students, this is lesson 141. This is the beginning of the 1-4 lessons. In these lessons, we're going to learn how to determine from equations if two lines are parallel and also determine if 3 points are collinear. And we're going to also learn how to model a set of linear data with an equation and to use technology to help us come up with a linear equation called a linear regression. All right, first thing we're going to do is we're going to skip to the next page. And we're going to go down to number 4. Actually, let's do number 3 first. It says, without graphing, decide which of these equations represent parallel lines. So if we could graph these lines, it'd be pretty easy to tell if they were parallel. But remember that if two lines are parallel, then that means that they are going up at the same rate, which means they have the same slope. And in an equation, the coefficient represents the slope. So these two lines have the same slope. And this one appears like it has the same slope, but because of this 2 here, that means it's not a linear equation. So we're going to pick these two. And the reason we did is because both have a slope of 2. All right, now we're going to do number 4. It says consider the line y equals 5x plus 4. A second line is parallel to this line. What do you know about the equation of the second line? Well, from what we just saw, if they have the same coefficient in the equation, that means they have the same slope, and that means they're parallel. So the second line that's parallel to this line has to have this coefficient 5. So we know that the coefficient is 5. Okay, now part B says write an equation for the line parallel to y equals 5x plus 4 that passes through the origin. If it passes through the origin, that means we know that it goes through this point 0, 0. And since we know it's parallel to this line, we know that it's going to have this part of the equation the same. And for it to pass through the origin, we need this equation, y equals 5x, to be true, that when x is 0, so if we take 5 times 0, y is equal to 0. So if we had to add something to do that, we could, but since 5 times 0 is 0, it's already equal to 0. So we don't need to add a y-intercept. And we also know that if it passes through the origin, it's a direct variation. And a drift variation equation doesn't have a constant term, just has some number times x. So that's the answer to that question. Part C says write an equation for the line parallel to y equals 5x plus 4. That crosses the y-axis at the point 0, 3. So where it crosses the y-axis, that's the y-intercept. So this is the y-intercept. And we know that when we write any equation in this form, that the constant term b is the y-intercept. So we need that to be 3. And since we need it to be parallel to this, we know that the slope is 5. So there's our equation, y equals 5x plus 3. Part D says, write an equation for the line parallel to y equals 5x plus 4. So it's parallel, so we know it's going to have that in common. That passes through the point 211. We have a hint here, the data pair 211 must satisfy the equation. So that means if I take, so if 2 is my x and 11 is my y, so, and I know in my equation I'm going to have this plus some constant term, some y-intercept, and I know that if I take 5 times my x value, which is 2, and add this constant term, it has to equal my y value, which is 11. And 5 times 2 is 10. And I know that 10 plus 1 is 11, so that means b has to equal 1. So my equation is y equals 5x plus 1. All right, let's go on to the next problem. Number 5. Says a line has the equation y equals 3x minus 1. Find an equation for the line. I'm going to let you go ahead and try that. That'll be one problem I'm going to ask you to do. Okay, and number 6 says a line has an equation y equals 4. It says graph the line, so I'm going to graph the line here. All right, so it says graph the equation y equals 4. Well, y equals 4, notice it just has a constant term, there's no slope, which means if there was a slope, it would be 0. So this is the same line, because 0 times x is 0, 0 plus 4 is 4. So my slope is 0, and my y-intercept is 4. So my line goes right through there. Now it says, find an equation for a line parallel to this that passes through the point 36. I'm going to go to the point 36, that's right there. And the line that's parallel to that will look like this. Oh, a little higher. But, so there's that line, and we need the equation for that. Well, if this line here is y equals 4, and this line here has a slope of 0 also, and that would be y equals 6. All right. Okay, we're going to do one more problem, but that would be on right here, develop and understand A. Get this out of the way. Okay, first of all, to do this next problem, we have to define something. And our definition is points that all lie on the same line. They're called collinear points. Okay? And collinear points in this graph are all the ones that are on the same line. So that would be C, B, and A, and they're all collinear. Okay? And what we're going to do is learn how to tell if points are collinear. And the way we're going to do that is we're going to use the slope. Because if you think about those 3 points, if I do the slope here, that slope is 2/3. If I do the slope here, that slope is also 2/3. And if I go all the way from C up to A, that slope is up 4 over 6, and 4, 6 is also 2/3. So if 3 points are collinear, that means that the slope between those 3 points is always the same. So we're going to use this formula to help us find the slope here. Slope formula. And so we're going to check out these points here. So I'm going to use these 2 first. I'm going to do 26 minus 5. I'm going to divide that by 10 minus 3. And that equals 21 over 7, which is 3. Now I'm going to check the slope between these 2. I'll put that in a different color so we can see that. So for that, I'm going to do 26 minus 20 for my y values, and 10 minus 8 for my x values. And if I subtract those, I get 6 over 2, which is 3. Since the slope between these 2 is 3, and the slope between these 2 is 3, I know that those 3 points are collinear because there's the same slope between them. If they weren't collinear, that means that they would be like maybe this between those 2 points, and then up here, and notice what happens then. The slope changes. All right, so go ahead and try maybe number 8 if you'd like before we meet in class next time, and remember to go back and do that other one that I asked you to do, number 5. All right, other than that, we'll see you in class.